The main goal of the VOEIS project is actually to collect sensor readings from various lakes and streams, particularly Kentucky Lake and Flathead Lake, and then to make that data available for researchers as well to other people who are interested in that information, ranging all the way down to fishermen.
Flathead Lake is a natural lake. It is very, very deep. It's very cold. It was carved by glaciers. Kentucky Lake, by contrast, is a reservoir created by the damming of the Tennessee and Cumberland rivers. But the lakes have one thing that is dramatically in common, and that is that they both produce vast quantities of data associated with the sensors. And that's what this project is really about.
Water quality is something that needs to be monitored with relatively high temporal resolution. In other words, you need to monitor it continuously in order to get a good picture of what's going on.
We have a long-term monitoring program here that has been ongoing since 1988. The sensor technology allows us to couple the long-term monitoring database with this high-frequency database that we're generating hourly, daily, weekly with the sensors. And we're trying to tie those two things together.
We have one fixed site, and then we have 3 mobile sites. 2 are in the water, and then there's one which will be deployed based on the question we want to ask.
The Flathead Lake Environmental Sensor Network is comprised of 9 different weather stations that are located around Flathead Lake. All of those weather stations are collecting a standardized suite of variables including wind speed, wind direction, air temperature, relative humidity, and so forth.
We, at this end, are the data gatherers. We are putting the sensors out into the lake, and then other people are also putting out smaller versions within Kentucky, and in some cases actually inventing certain types of new sensors.
We've developed a whole suite of new sensors that we can now take out into the river, take into the lakes, and collect new data.
With the VOEIS project, I'm helping create sediment sensors for detecting how much sediment is transported, how fast, and in what spatial location in our streams. We need to know how much mud is in the water, how much silt, how many particles per liter. We do that by measuring how cloudy the water is. We have some light sensors. And the other main thing we measure is the water flow speed. So we have these bendy things, and the water hits it, bends it, and we get a bigger electrical signal the more it bends. And we're focused on making these low cost so we can put lots and lots of them out there.
You want to be able to do it on your own, and this is what this technology is doing for the community. Is you can actually build it yourself and test it yourself out in your local rivers.
And anyone with enough knowledge and just the typical electronics techniques can get these designs and put the sensors together and maybe put them in their own backyard. And that's great for both the workforce development and the sustainability of the whole project. Our project comes alive in the summer. Part of the University of Louisville's task is to have 2 undergraduate research assistants every summer making sensors.
When you're out in the real world, most times you're behind a desk or in a plant as an electrical engineer. You're not really out in the field, but here we were going up waist high in water and just really enjoyed getting out to nature.
We're creating kind of a microscope or even a telescope for the Earth. So there's going to be these sensors, and you'll be able to look in, instead of a lens, you're looking into a computer screen, and you're getting all this data. So we can look for long-term changes in the environment and the climate.